Okay, the next organizational method that we're going to use in statistics is called the scatter plot. The scatter plot is when we're using two variables. So you have some set of data matched up with some other set of data, and what we can do with that is plot them in the XY plane, just like this. And when I plot the points, you might kind of see that, hey, they all seem to fall in this line here. That's because I use data that's very correlated to each other. So if you can throw in a line, we call that a line of best fit or trend line. So line of best fit or trend line. And then off of that trend line, if a point is off a little bit, we call that the residual. Like how much off is that? That's called the residual amount. The correlation coefficient is typically we use the variable r, and r represents, if it's a 1, it means it's a perfect line, that all the points that are in our data set actually fall in the line. So this would not be an r of 1, but pretty close. If it's an r of 0, then it's not correlated at all. It would be a scatter plot looks something like this. If the data is perfectly correlated and has a negative slope, then we have r of -1. So r of +1 is a line that's perfect, and if there's residuals coming off, then it's not actually a 1. It's going to be, like 0.9 or something like that. R of -1 is a negative slope going down and to the right, and then r of 0 means not very correlated. Now, correlation does not mean causation, and just because we can use things to predict in correlation doesn't mean that it's an actual causation. So example would be like in the past there was more lead in the environment used for paint and stuff like that, and we saw that as the amount of lead in the environment decreased, we saw also crime decreasing. So there is a correlation between the amount of lead in the environment and crime. Now, does lead cause crime? So that's a big question. It may or may not cause crime to be increased. But to prove causation, you have to go kind of one step further beyond correlation, and that's where you set up a control and a test subject. So in the control group, you these two groups of people or animals or something that you're testing to find if there's causation, they have to have very similar characteristics, and then one group gets the factor and the other group doesn't get the factor, and then you see does it correlate more in the case where the factor is applied than when the factor is not applied. So this was what is used to prove that smoking causes lung cancer, right? So they have a group of people that has very similar characteristics, one group that smokes and one group that doesn't smoke, and you find out that indeed there is a causation factor with smoking. So that's how I just wanted to bring that up, that correlation does not necessarily mean causation. And you could have things like, oh, there's the amount of ice cream that gets eaten, more people eat ice cream today than did in 1900, right? And also, crime might have gone down. So you might say, like, is there a correlation there? Well, there might be a correlation in the graph, the scatter plot, but it doesn't mean causation, right? So correlation does not mean causation is an important fact. We're going to go ahead and do a more complicated scatter plot now, and we're going to use GeoGebra to do it. So everybody, we're now plotting our data in GeoGebra. What I did here was I came up with 10 countries. These are the top 10 most populated countries in the world, from China to Japan. The United States is the third most populated country in the world. And I got, those values are the population in millions, so this is 1,356,000,000 people live in China, and 319 million people live in the United States. And then I also got values for the amount of electricity produced by each country in kilowatt hours, millions of kilowatt hours. So this would be 4,977 million kilowatt hours of energy is produced in China, and have all those values there. And then I also did exports in billions of US dollars. So you can see that China exported $2,210,000,000 dollars worth of exports. So I went ahead and graphed these first two quantities. So right here you see the point. So the population is on this axis, and energy production is on this axis. So you can see that China, with its 1,300,000,000 people, produced 4,977,000,000 kilowatt hours of electricity. So you can see that this scatter plot is not very correlated, but what I'm going to do is have GeoHero tell me what the correlation coefficient is. So I'll say R is equal to, and then I just type in correlation coefficient, and it's right here. And then it tells me to put in a list of points, which I already made the list of points. It's going to be list 1. And I hit enter, and it says the R is 0.58. So the correlation is not, not a perfect line, would be 1, and not correlated at all would be a 0. So it's somewhere in between 0 and 0.5. And you see it's pretty much a positive slope. Now, I can have it draw a line of best fit. I'm going to do that and say f of x equals fit line is the command, fit line. And then I tell it the list of points. And it's in list 1. And there it is. So this line over here, and you see the slope of the line is 2.2x plus, so the initial value 371. So you can kind of look at the data and the residuals. So this one is below the trend line. So what makes you think that this one would be so far below the trend line? Let's see. This is India, right? So it has a lot of people, but not quite as much energy production. Maybe because, I don't know, they don't have very big cities. It's more spread out. China produces a lot of energy because they're doing a lot of exports. The United States produces a lot of energy because of it's highly industrial. So like the more industrial a country is, probably the more above the trend line it's going to be, and that's how you can explain the residuals. And these countries down here, so this one, let's see, 160, so Bangladesh, Nigeria, and Pakistan are kind of grouped down here, and they're not very highly industrialized, but you can see that there. Now, I can do some other lists of points and graph some more scatter plots, so let's try that. Let's just delete all this. Okay. And now let's compare electricity with exports. So the more electricity you use, probably the more exports you're going to do. So let's check that, create a list of points. So I go select it, create a list of points, okay. And let's see, make sure all that data is in there. Alright, I think we got them all. Alright, so I'll do a line of best fit. F of x equals fit line, and we'll use this one. And let's find out what our correlation coefficient is. So say R equals correlation, and this one, let's see, this is 1. Look at that, that's actually really good. The correlation coefficient is 0.99, so it's pretty close approximation there. So what do the residuals mean? Let's see. So J, what is J? I want to turn this around so it'll be the values that I can understand a little bit. Okay, so this one is the 936, which is Japan. Okay, so Japan has electricity and export. So it looks like they're a little bit more efficient, right? So they're doing more in exports with less energy. And let's see. So what else? What about this one? The 985. So it looks like India is not very efficient. So that's the one that's probably the furthest off of the line on the downside. So they're not very efficient with electricity as other countries. And the United States looks like we should be more efficient, but China looks like it's pretty efficient. So I guess that's how you can look at those residuals, is if they're above the line, they're using, or they're getting more exports per their amount of electricity. So that's kind of the usefulness of understanding what residuals are and mine best fit and